Hello students, welcome to my lectures. In the last class, we have seen some problems on curl, gradient and divergence. In this class, we will see some identities among gradient, curl and divergence. Okay, fine. Let us take the first identity. The first identity as follows. The first identity is grade divergence of scalar function phi multiplied with the vector function a is equal to gradient of phi dot with a plus phi into del dot a. So this is the problem. Okay, fine. Let's see. We use the sigma notation. So divergence. Here remember phi is a scalar and a is a vector. A is a vector. Here both differentiable functions here. Phi and a both are differentiable functions. Okay, fine. Now start with the divergence. LHS will be divergence of phi a. Now we need to follow sigma notation. That is sigma I dot dou by dou x of phi a. Then similarly j, similarly k, then dou by dou y, like this will come. This implies sigma I dot dou by d. Follow the product rule. Phi into dou by dou x of a plus a into dou phi by dou x. Okay, fine. Now take the dot product. So this I'll write will be like this. Sigma, don't forget the notation, sigma I dot. So we can put phi will be outside. Now dot product I dot product with dou by dou x of a. This is point. The next plus I. So you do like this. I into dou phi by dou x dot with a. రాయొచ్చు కదా, నో ప్రాబ్లం కదా. సో ఏం చేసాం ఇక్కడ, I డాట్ ప్రోడక్ట్ విత్ phi ఇంటూ dou a by dou x. సో వెక్టర్ని వెక్టర్తో డాట్ ప్రోడక్ట్ చేయాలి. మళ్ళీ ఇక్కడ కూడా I డాట్ a, ఇక్కడ దీన్ని d5 by dx ఎక్కడ రాసినా ఓకే. ఓకే, నేను అలా రాసుకున్నా. నెక్స్ట్ చూద్దాం ఎలా రాయొచ్చు. ఓకే, సో ఇప్పుడు ఏమవుతుంది, ఇది this will be is equal to I డాట్ dou a by dx అంటే ఏమవుతుంది, ఇది డాట్ ప్రొడక్ట్ I డాట్ dou a by dx, dou a by dou y, dou a by డైవర్జెన్స్ అయినా డైవర్జెన్స్ ఆఫ్ a. సో phi multiplied by divergence of a plus ఇక్కడ I dou phi by dou x, then J dou phi by dou x, then K dou phi by dou z. then అవన్నీ చేయడం వల్ల ఏమొస్తుంది మనకు gradient of phi dot with. So this is what we need to prove. Okay. So phi into del dot A plus phi into dot A. Okay, very simple to prove. Okay. Next we'll go to the another identity as follows. Another identity as follows. The identity is prove that curl of is equal to gradient of phi curl with A plus phi into del cross A. Okay, so let's see how to prove this. The same manner, del cross phi A, same phi is a scalar and A is a vector, both are differentiable. So we follow the shorthand notation. Del cross phi into A. Del cross phi into A will be is equal to sigma notation I cross dou by dou x of phi into A. Now you do this sigma I cross product rule phi into dou A by dou x plus A into dou phi by dou x. Okay. Now you take this cross product inside. I'm taking cross product inside. Sigma notation అది మార్చకండి. So vector and vector తో చేయాలి. I is a vector cross product with dou A by dou x. Okay, phi అన్నది కాన్స్టెంట్. then next ఇక్కడ కూడా అంతే, vector and vector తోటి చేయాలి ప్లస్ I into dou phi by dou x cross product with A. Okay, fine. What is this? I cross something. Curl కదా ఇది, curl of phi. I cross. So curl of A with phi. I cross dou by dou x, then J cross notation అని మనం వచ్చేస్తే ఫైనల్గా దీన్ని ఏం రాయొచ్చు, del cross A with phi ప్లస్ I J. సో ఇప్పుడు ఏమొస్తుంది, gradient of phi cross product. This is what we need to prove. What we need to prove. Okay, so this identities will be helpful for us. Okay, next we'll move to the another identity. Another identity as follows. Prove that identity gradient of a scalar రావాలి ఇక్కడ, two vectors, dot product of two vectors A dot B will be is equal to A plus A dot del into B plus B cross curl of A plus A cross curl of B. Okay, fine. Now we need to prove this result. So the result ఎలా prove చేస్తామంటే, first I'll take these quantities. ఈ క్వాంటిటీ తీసుకుందాం, మళ్ళీ తర్వాత ఈ క్వాంటిటీ తీసుకుందాం. ఈ రెండింటిని సింప్లిఫై చేద్దాం, ఏమొస్తుందో చూద్దాం. సో ఫస్ట్ I'll take the quantity A cross product of del cross B. Okay, so A cross product with del cross B. Del cross B ఎలా రాస్తాం? సిగ్మా నోటేషన్ I cross dou B by dou X. అంతేనా? దెన్ నెక్స్ట్ ఏం వస్తుంది? ఇది సిగ్మా నోటేషన్ A cross product with I cross dou B by dou X. ఓకే, ఫైన్. సో దీన్ని ఎలా రాయొచ్చు మనం? బ్యాక్ మైనస్ క్యాప్ మెథడ్. సో 3 వెక్టర్స్ ఉంటే A క్రాస్ B క్రాస్ C ఉంటే దాని సింప్లిఫికేషన్ ఎలా రాయొచ్చు? A డాట్ C మైనస్ క్యాప్. ఓకేనా? ఆ రూల్ ప్రకారం A B C. సో దిస్ విల్ బి రిటన్ యాజ్ సిగ్మా నోటేషన్. సో బ్యాక్ అంటే I A dot dou B by dou X into I minus cap A dot B. A dot I into dou B by dou X. Back minus cap. అంతే, రాసేసాం. ఓకే ఓకే, దీన్ని ఇంకొద్ది సింప్లిఫై చేద్దాం. సో దిస్ కెన్ బి రిటన్ యాజ్ సిగ్మా, ఇలా రాయొచ్చా? I ఇంటూ A dot dou B by dou X మైనస్ ఇదంతా ఒకటి వెక్టర్, దీన్ని ఇట్లా రాయొచ్చు. A డాట్ I into dou by dou X of B. Okay. ఓకే, యాక్చువల్గా ఇక్కడ 2 సమ్మేషన్లు పెట్టాలి మనం. డెల్ క్రాస్ బి సమ్మేషన్ ఒకటి, ఈ సమ్మేషన్ ఒకటి. సో ఎక్కడ వస్తుంది అది? ఇక్కడ A క్రాస్ డెల్ క్రాస్ బి. యా, పర్ఫెక్ట్, నథింగ్ రాంగ్ హియర్. నౌ we use the sigma notation. Sigma notation మనం వాడితే ఇక్కడ ఏమొస్తుంది? ఫస్ట్ టర్మ్ I into A dot dv by dt, మళ్ళీ తర్వాత J into A dot dv by dz. అంతేనా? ఇక్కడ అంటే ఇప్పుడు ఏం వాడచ్చు మనం? ఇక్కడ దీన్ని I into A B C అలా వస్తూనే ఉంటాయి కదా. సో దట్ ఈస్ సిగ్మా నోటేషన్ అలా పెడదాం. సిగ్మా keep the notation like this, I into A dot dB by dx. Next come here, minus sigma notation A dot I into dou by dou x of B. ఇక్కడ sigma notation వాడదాం. So next step also I'll write like this, sigma notation I into A dot dou by dou x of B minus sigma A dot, so A అన్నది ఎలివేట్ సమ్మేషన్ కిందకి రాదు, we can put outside also. So A dot ఇక్కడ sigma I into dou by dou x of B. ఓకే, సో ఇప్పుడు ఇది ఇలాగే ఉంచుదాం. నెక్స్ట్ స్టెప్ లో ఎలా మారుతుందంటే things will be like this. This will become sigma I A dot dou by dou x of B minus A dot product with what is this entire quantity? Gradient of B. Okay, so finally what we have, మనం దేన్ని స్టార్ట్ చేసాం, finally we started for A cross del cross B అంతేనా. దీని నుంచి మనకు వచ్చింది ఏంటి, సిగ్మా I into A dot dou B by dou x minus A dot del into B. దీన్ని తీసుకొచ్చేస్తే A క్రాస్ del cross B plus A dot so finally I have sigma I can A dot dB by dx. ఓకేనా. సిమిలర్లీ ఇప్పుడు మనం ఏ క్రాస్ డెల్ క్రాస్ బి అని రాసాం. సిమిలర్లీ ఇది బి క్రాస్ అంటే కర్ల్ ఏ ఇస్ ఈక్వల్ టు ఏమవుతుంది, యాజ్ యూజువల్ గా పైన సిగ్మా I B dot dou A by dou x minus B dot del into ఇది ఇటువైపు వచ్చింది. అప్పుడు మనకి ఏమొస్తుంది, B క్రాస్ del క్రాస్ A ప్లస్ B dot del A is equal to sigma I into so B dot dou A by dou x. You can make it as an equation 1 and you can make it as an equation 2. Okay, fine. Now you can add 1 and 1 plus 2. When I add 1 plus 2, what I'll get here? 1 plus 2. Left hand side you see 4 terms are there. A cross del cross B plus A dot del B plus B cross del cross A plus B dot del A. That is equal to right hand side you check. Right hand side two terms, I'll combine the two terms, sigma notation I common. So what I have, A dot dou B by dou x plus B dot dou A by dou x. Okay, now you see the right hand side. We have 3 more terms. So A dot dou B by dou x plus B dot dou x. So this right hand side term is of gradient. So this is of gradient of, so this is the gradient of A dot B, A gradient of A dot, okay. So this is what we need to prove. So RHS is gradient of A dot B. LHS is, that's what the terms involving A cross curl B plus B cross curl A plus A vector multiplied with B dot del operator plus B vector multiplied with A dot del operator. Okay, so it's an important identity. This we use in electricity, magnetism, in physics, many other places. So see how you prove. So here we are just following the notation method. If you are not going through the notation method, let's say for example you are taking A vector and B vector, that in that way also you can prove LHS is equal to RHS, but that is a tedious job. Don't go that method. You will get answer, but it is a tedious job. Okay, that is what some people can try like this also. So you can try like this also. Take the A vector will be is equal to X component I cap plus Y component J cap plus Z component K cap. Then B vector you can take like this. So B vector will be equal to X component I cap, Y component J cap plus Z component K cap. So now you do everything. So in this manner also you'll get the same answer. But it takes a little bit time to do each and every term. So better to follow the sigma notation. Okay, fine. I hope it is clear. So now we'll go to the next problem. The next problem is again an identity. I said in this class we'll discuss the identities. All are identities here. The next identity as follows. So write the identity first. In the previous problem, gradient of scalar product of two vectors we have taken. Now I'll take the divergence of definitely a vector, cross product of two vectors, A cross B. A and B are the vectors and they are differentiable also, A cross B. Then this will be is equal to B dot product with curl of A minus A dot product with curl of B. So this is what we need to prove. Okay, so as usual we start with the shorthand notation technique. So divergence of A cross B, divergence of A cross B, this will be is equal to sigma notation. I'm writing I dot dou by dou x of A cross B. Now you do the product rule differentiation. Sigma I dot dou A by dou x cross product with B plus A cross product with dou B by dou x. Okay, fine. So now this will be is equal to, you can take the I inside. If I take I inside, the first term will become, of course sigma notation is there, don't forget the sigma notation. I dot product with dou A by dou x plus B plus I dot product with A cross dou B by dou x. Now I will conveniently write these terms. So we have a formula. According to that formula, if there is A dot B cross C, this can be written as B dot C cross A. This can be written as C dot A cross B. That means here dot and cross will be interchanged. A cross B dot C. Okay. This is the formula. Okay, according to that formula, here dot and cross is, sorry, this is cross. Dot and cross will be interchanged. Dot and cross will be interchanged. This is the cross. Now interchange the dot and cross here. So this, with this, here it can be written as sigma I cross dou A by dou X dot product with B. Now you do one thing. So you interchange these two. A cross B is equal to minus of B cross A. You do this thing here. Then minus of I dot dou B by dou X cross product with A. Okay. This is closed. Now it will become the first term. This is as well sigma I cross dou A by dou X dot B minus, here again dot product and cross product will be interchanged. Okay, minus sigma I cross dou B by dou X dot with A. Okay, now what is this curl? Is the curl, and here also it is a curl. So that is curl of A dot product with B minus curl of B dot product with A. Okay, this is what is proved. We need to prove the identity we have proved. So finally divergence of two vectors A and B, that is cross product is again a vector, will be equal to this one. Okay, as I said earlier, you can again prove in the same manner. Take A vector in the form of component form Ax and B vector in the component form. So take A vector will be is equal to xi cap ayj cap and azj cap. Similarly, B vector bxi cap plus byj cap zk cap. Then as usual you take the A cross B, that is LHS. Now del cross A, first you calculate, then take the dot product with B, RHS first term, then del cross B dot A second term in the RHS. Now you manipulate, you will get the same answer. Okay, but it is lengthy procedure, but you will get the same answer. Okay, fine. Now we'll take another problem. So the problem is again the same identity. There is another identity. Okay, fine. Go to that another identity. The identity as follows. So curl of vector, curl of a vector is cross product of two vectors A cross B is equal to A into divergence of B minus B into divergence of A plus B dot del to A minus A dot del into B. Okay, so this is an identity we need to prove. Let us prove that. Then again, we'll follow the shorthand notation. It is easy. The first LHS is del cross A cross B, sigma notation, I cross dou by dou x of A cross B, then sigma I cross, you do the product here, dou A by dou x, cross product with B, plus A cross dou B by dou x. Okay, fine. Now you take the cross product inside, then sigma notation is present. I cross dou A by dou x cross B plus I cross A cross dou B by dou x. Okay, fine. Now, as usual, we can use the formula back minus cap. So apply here and apply here. Then that will be converted into gradient. Back minus cap. So I'll apply here. Cap C A B dou A by dou x. Back minus cap C back minus cap I dot dou A by dou x into B. Okay, the first thing is over. Then next, plus here also back minus, don't forget the sigma notation. The sigma notation is compulsory. Back minus cap A dot C or C dot AC into back BAC back minus cap A dot B okay, fine. So now this is the quantity we need to express the 3 terms. So 3 terms వస్తాయి ప్రతి దాంట్లో. Okay, fine. So ఇక్కడ B dot I అన్న I dot B అన్న సేమే. Okay, next ఏం రాద్దాం దీన్ని? Sigma notation ప్రతి దానికి రావాలి ఇక్కడ sigma notation. So when I get the sigma notation here, can I write this term will be like this? Sigma B dot B dot or otherwise we take B outside. So we take the B outside. Take the B outside. Let's see here. Okay, fine. చూడండి ఎలా చేద్దామంటే, సో రిపిటేషన్ టర్మ్స్ లో బిఎం రాదు కాబట్టి అండ్ టేకింగ్ ద బి అవుట్ సైడ్. బి డాట్ సిగ్మా notation I into dou by dou x of A. Okay, fine, that is the first term. Second term minus sigma notation I dot dou A by dou x. Of course, nothing to change here. This is B. Then similarly plus here this is nothing to change in this term also. I dot dou B by dou x into A But here, so I dot A and A dot T same, then I can pull out A outside, dot product sigma I into dou B by dou X. Okay. Now what if this will be? I into dou by dou X, J into dou by dou Y, K into dou by dou Z. That is a gradient. B dot del operator. So of course A minus, what is this? I dot dot product undi with vectors ante divergence. Del dot A into B. This kuda plus del dot B A minus I into dou B by dou X. Gradient వచ్చేస్తుందా? So A dot gradient of B. Okay. So B dot gradient ఉన్న A dot gradient అన్న రెండు సేమ్. Minus divergence of AB plus. So first term A into divergence of B, second term B into divergence of A, next term so this will be divergence here and this will be divergence here. So this can be written as finally. So first we write divergence terms. The first term I'll write as divergence of B with A minus divergence of A with B, then plus B dot product with del operator multiplied by A up minus A dot product with del operator into B. So let's prove. This is what actually we need to prove. Okay. So curl of A cross B. This is the curl of A cross B. The curl of A cross B will be is equal to this expression. Okay. So in a similar manner, this also can be solved in the same manner. What is the same manner? So you can try like this. That take the A vector will be like this: Ax I cap, then Ay j cap, Az k cap. Similarly, B vector is Bx I cap, By j cap, Bz k cap. Okay, now as usual you determine A cross B. You determine del dot A, del dot B. Okay, del dot A term is a del dot B term. Divergence of B is a divergence of B. Then you component B dot del A dot del. Sorry. Yeah, A dot del. ఈ టర్మ్స్ కనుక్కొని RHS, LHS మీరు సేమ్ అని ప్రూవ్ అయినా చేయొచ్చు. So this is again the lengthy procedure, but you can try. Okay, fine. So you can try. I'll give you some work to you. Try yourself. I'll give you some work. So try yourself. The first one, prove that curl of a gradient of some scalar function will be is equal to 0. Curl of grade phi is equal to 0. That is, in words, curl of grade phi will be is equal to 0. Then second one will be divergence of curl. divergence of curl of a vector function is equal to 0. Divergence curl f is equal to 0. Then third one, you prove that third one will be so one of the important theorem, identity things. Del cross del cross A, curl of curl A is a vector. Curl of curl A is gradient of scalar quantity divergence of A minus del square A. Okay. This you try. A is a vector quantity here, obviously. Okay, you try these three identities. If you are getting, it is okay. Otherwise, I'll do in the next class. Okay. Thank you. Thank you very much. And we'll stop this class. Okay, fine. Thank you.